Okay, so last week we learned all about box models and how to draw one or make one that represents a chance process, right? So we are going to look at some more today. So this one is not in your notes. So if you want to just listen and watch, you can. If you want to actually write it in your notes, that's up to you. But anyway, so we have a child plays a game in which she has a 30% chance of scoring 5 points, 50% chance of scoring 3, and 20% of scoring 1. If she plays it 20 times, what is her expected score? Give or take how much? So think of the box model. Hold on, let me go back. What would the box model look like? Because we have to represent the percentage and the points, right? So any ideas? Well, first of all, what are percents always out of? 100. And they're 10, so just make 10 multiples. So 10? Well, what if we make it even easier on ourselves and know, okay, percent's always out of 100, and we know 30 plus 50 plus 20 adds up to 100% like it should. So let's just make the box have 100 tickets since it's percentages, right? See what I'm saying? Nope, because remember we just have to go. Okay, so if there's a 30% chance of scoring 5 points, I'm going to do 30 tickets with a 5 on them. See what I'm saying? And then I'm going to go 50% chance with a 3 points, right? 50% chance of scoring 3 points and 20% chance of scoring 1 point. I don't know why it does that. And then she's playing this 20 times. Okay, so how would we find her expected score? That is the EV sum, right? She plays, she gets points, plays again, we just keep adding up her score. That's EV sum. So we would have to know what? Average of the box, right? So what is the average of the box? Actually, I'm going to write that over here. Average of the box, how could I do that? 30 times 5 plus, yep, 50 times 3, right? Sorry, I'm remembering, plus 20 times 1. And we divide all of that by how many tickets? 100. Which is 100 tickets. Okay. All right, go. Find that to the nearest hundredth since it is money. No, it's not money. Never mind. Just round it to the 10th place is fine. Divide it by 100. Why did I divide it by 100? There's 100 tickets in the box. Because since they're percentages, I just made it 100 tickets for the percent. Yipper skipper. So 320 divided by 100, isn't that 3.2? Yes, ma'am. All right, is that what you guys got? So 3.2 is the average. Why is it doing that? I don't know why it does that. So if that's the average, how would we find the EV sum? Yes, so we take the average of the box, which is the 3.2, and we times it by how many draws we're making from the box, which is 20. And that's going to be what we expect her, how many points we expect her to win. Which would be what? 64 points. Give or take. And then to do the give or take how much, that's the SC sum, which I'm not going to go over that right now because the SD we got 3 anyway. So I'm going to wait to go over that. So that's how much we expect her to win is the 64 points. Okay? All right, so that's just a review from last week. So I also want to talk about when you're making a box model, like, for example, this first one, if we want to count how many times something happens, the box has zeros and ones. So like if you're just counting, so like this one with the 1, 2, 3, 4, 5, 6, remember we had an example, you roll a die, you get paid what you roll. So that would be like this, okay? Well, if you only got paid when you rolled a 6 and you got 0 for everything else, then it might look like this because you're only counting the 6, right? So you have to look at the example and think, okay, what are we counting? What's the only thing we're counting? And that might be the only one that has a number on the ticket, okay? Everything else would be zeros. So you got to read the question carefully, all right? So, wait, do you guys have this in your notes? Okay, well, actually, I'm going to come back to that one in a minute, okay? Anyway, because you guys have this, right? Okay, so with the normal curve, everything always comes back to the normal curve, right? I told you guys it's magic. So for a large number of draws, so if we take a large number of draws, we keep drawing from this box, whatever, the sum of the draws will follow the normal curve with average EV sum and standard deviation SE sum, which we've talked about this. Sorry, whenever it does that, just ignore it. I don't know. It's annoying. Okay, so what the average of our normal curve, if we sum the draws, we plotted them, it should follow a normal curve, and the average would be what we expect, that EV sum, and then the standard deviation would be the SE sum, okay? Now, if you go back to the empirical rule with how many SDs away, you guys remember percentages? How many within one SD? Ooh, close. 68. 68. What's the next one? 95. Okay, so 68% of the time, the sum of the draws will be between the EV sum minus the SE and EV sum plus an SE. So just within one SE. Okay? 95% of the time, it will be within 2 standard errors. Okay? Because it follows the normal curve. So it's going to have that same rule. 68% within 1, 95% within 2. And then to find the chance of observing that sum, we could find the z-score. Remember z-score from way back when? It's the observed sum. Did I blank any of this out? No, I didn't. Observed minus EV divided by SE, okay? There's also another way to do it without finding the z-score, even though the z-score is really important. But okay, so let's look at the one you do. Oh, I have this note. I didn't print this off for you, but this is really important. Okay, it doesn't matter what's in the box. So whether you have, like whatever you have, it does not matter. Because the histogram for the tickets in the box doesn't have to follow the normal curve. So say I had 90 zeros and 10 ones. If I graph that, it would be like this, right? It'd be a histogram with like this. It would not be the normal curve at all. But that doesn't matter. The sum of the draws will always follow the normal curve, even if the tickets in the box are just zeros and ones. So in fact, we don't even need to know what's in the box. If we just know the average in SD, we can find out information about it. Okay? That's the beauty of the normal curve, is we don't have to know what's in, because we know eventually the more draws you do, it's going to follow that normal curve. Okay. So let's look at example 11. This is the one you guys have, right? Okay, so we're going to roll a die 100 times, and we're just going to count the total number of spots that is shown on the die, okay? What is the chance the total number of spots is more than 367? Okay, so your guess is 50%. Okay, all right, so let's draw a box model that shows this. So I want you, with your partner, to draw a box model that shows this scenario. Go. All right, McKaylee, Mariah, what did you girls say? What was in the box model? Because if you, okay, so we know the arrow's 100. Hey, that is a start. That is a start. But what are the possibilities when you roll a die? 6, okay? So we know there has to be 6 tickets. And what happens, like, what are we counting? We are counting the dots. So we do want to know what's on each face of the die, right? So then we would just go 1 through 6, like we have done this example before, right? Does that make sense? Because if you're going to roll and just count the number of spots on the die, then you want each ticket to show how many spots there are. Question? I would say every notes page is important. That's why I take the time to copy and cut them out. But that's what?
I know. I've been saying that for years.
What?
She does it with parentheses too.
No. Remember last week I didn't. I know. I should go on the, the talent show.
Like
Yeah, America's Got Talent. You know what my talent is?
Like you guys name a number.
Name.
This big.
Okay, average of the box. We've already done this example. So wasn't the average 3.5?
Yeah.
You guys saying yeah without even looking.
Well, it's
3.5. But what's the SD? That one I don't remember. You guys have SD? SD from the first day we did box models. When we had examples 6, 7, and 8, I printed for you. 1.7.
Wait, that was with 10 rows. It doesn't make a difference. Never mind.
Yep. 1.7, 3.5 was the average. Yeah, this was the very first box model we did.
We should just
Okay.
that.
I know. I know, right? So then the EV sum is going to be what? Because we are wanting to find the sum because we want the total number of spots. So that's going to be
35.
So yeah, so it's just going to be 3.5 times the number of draws. Is it 35?
No, it's 350.
350. So we expect the total spots to be 350. Okay, well, let's find out what the give or take is. So SE sum is the standard deviation times what? Square root of the draws, which is just going to be 10. So give or take 17.
So that's reasonable. That is 95%.
That is reasonable. So I'm going to draw the normal curve and label what we're talking about. So if you have room somewhere, this should help you. So if we keep drawing from this or keep rolling the die, okay, we expect, which will be the average, to be 350 would be the total number of spots if we add up after 100 times, right? And then each SD, or in this situation will be a standard error, is what? 17. So that means for each SD, I would just add 17 to 350 or subtract, right? So then this would be 367. This would be whatever that is, 384, blah, 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 right? And I could label that if I wanted to. So now, if we want, what is the chance the total number of spots is more than 367? So what are we trying to find? What part of the curve? Yeah, we're trying to find this and greater, because we're trying to find, hey, what's the chance we're going to get more than 367? Okay. So you either remember that percentage on the normal curve, or if you don't, that's fine. It's menu 652. You guys remember? So get out your calculators, go menu 652, and what's the lower bound of the curve we're trying to find? 367. What's the upper bound of the curve? 10,000. That's the magic number. Good job. And then what is the mean? 350. That's the average of our normal curve, right? So we have 350. And then what's the SD, or in this case, SE of our curve? 17, yep. So once we do that, and then make it a percent if you want, so move the decimal over 2 times, 15.8%. So 15.8, so about 16. 15.8% of the time we would play this game, roll it 100 times, and get more than, our sum would be more than 367, okay? All right, so because this happens so often, that's why we can use the normal curve, because the sum will make a normal curve, and we can use that to approximate the chance of stuff, okay? All right, what about example 12? I want you to read through this with your partner and just set up the box model for number 12. Go. All right, have we set up this box model before? Yes, we have, right? So if we look at, okay, so $1 on red means we have 18 chances of landing on red, right? Where we win our dollar, and how many that we lose our dollar? 20 that we lose our -1, right? And we're going to play it 100 times, okay? Now we already know the average. Oh, you guys don't have it written down. It's on our quiz. Do you guys remember what the average was? Yeah, it was -0.05, right? And then the SD, do you guys remember what the SD was? I can review the shortcut with you, or I can just tell you. What do you want to do? Wait, the SD should be close to 0.5. I'm pretty sure it should be 0.5, because it would be large number. Wait. Hold on. Yep. So large numbers on the large number on the tickets, which is 1 minus. Ooh, I hate this pen so much. Well, it's just PowerPoint. When I'm not in PowerPoint, it's fine. 1 minus -1 times, what's the square root?
The square root of 20/8.
Times 20 over 38, right? Okay, so wait, this one may be 1 because it's 2 times 1/2. So is it 1? Plug it in. So 0.997, 0.998. Okay, so it is 1. Okay. All right. Okay. So now let's just answer the first question. What is the chance you can win more than 10 bucks? Okay. So if I'm going to play this 100 times, what is the chance I'm going to win more than 10 bucks? Let's hope it's a big chance, but I don't know. Because what's the EV sub? Because it's that times 100, so it'd be -$5. So we expect to lose $5. That's not good. S, give or take what? Wasn't it give or take 10? Because 1 times the square root of 100. So give or take 10, right? So let's just estimate. What do you guys think the chance of winning more than 10 bucks is? 5%, Weston says. Any other guesses? 5-ish? Okay. Less than that? You're saying 3? Okay. All right, so let's do menu 6. Because if I draw a normal curve to represent this, we expect to lose $5. Give or take 10, right? So then this SD, -5 plus 10 would be +5. This would be 15. This would be 25, right? Then I just go on from there. And I'm wanting the chance I win more than 10. So it'd be like here and above. That's what I'm trying to find. So if drawing the normal curve helps you, do it. Because you have to understand what this is asking, okay? And it also helps you to visualize what's the lower bound and upper bound, right? When you put it in the calculator. because sorry, my normal curve isn't pretty. So menu 652, what's going to be the lower bound? 10. What's the upper bound?
10,000.
Yep, just a really high number. What's the mean?
-5.
And what's the SD or the standard error?
10.
Is 10. All right, let's see how close we were.
Ooh, 6.68.
6.68. So that 5 is good guess. So 6.68% chance. So, you know, if you have a friend has a gambling problem and they want to play roulette, tell them, you know what, don't bet on red, because you only have less than a 7% chance of winning more than $10, right? Anyway.
The same for black, is it?
Yeah. Black or red. Or odd or even, right? Because those are the same bets. Okay. Okay, exactly. What is the chance you lose more than 10? Now, what do you guys think about that question? If we just found out the chance we win more than 10, then it will be the opposite, right? So 93.32% that we lose more than 10, right? So that's just the opposite amount or opposite event. Okay, and then I want you guys to answer, what's the chance you come out ahead? Now that just means you're positive any money. Does that make sense?
Yeah.
So I want you to work with your partner on that one. What's the chance that you're going to make any money at all, even if it's a penny? So the lower bound would be what? Just 0. 0. Yeah, but it is finding what's above 0. So it's not including 0. Anyway, so the lower bound 0, upper bound's 10,000. Keep the mean -5, SD 10. And what are the chances you come out ahead? 30. 31% chance, so a little less than a third that you would come out ahead playing roulette this way, okay? All right, so I'm going to go through some more examples. If you want to just watch and listen, you can. If you want to write it in your notes, you can. It's however you learn the best is up to you, okay? All right, so the same type of problem, it is the same problem, but $1 read 100 times. Wait, that's the exact same one, isn't it?
Yeah.
Win more than 10.
Well,
Since you come in.
Oh,
yeah, that's true. Yeah, because that's probably for each question. My bad. Okay, let's do this next one. So we have a multiple choice test, each with 4 questions. We've answered this already, right?
probably.
Yeah, because this was example 7 when we first did box models. So if you guess all the answers, like you don't know nothing, you're just, what is the chance you score more than 20 points? Okay, so I want you to work with your partner. We already have the box model because we have 3 options that we lose 2 points, right? And 1 that we get 5 points, right? And then do we have the average and SD for this one? We should. What was the average in SD? This was example 7, the first day we did box models.
Oh, the average is, wait, are you sure? Are you sure that's an example 7?
Or 8. Sorry, it's 8. 7 was still rolling the die. My bad. I just know it was on that sheet. Okay, what's the SD? 3.03? Okay, so now I want you to answer the question with your partner. What is the chance you score more than 20 points? So do we need to find the EV sum and SE sum? Yes, we do. Because that would be the average of our normal curve, and that would be the SD of our normal curve. EV sum is the average of the box times, sorry, I didn't do the number of draws, 20 questions, right? So negative 0.25 times 20. So what's that? Negative 5? Negative 5. SE sum is what? 13.5. Okay, so then if we had a normal curve, that is hideous. Sorry about that. Negative 5. I know, right? And then we add 13.5, so it'd be like 8.5 would be here, blah, 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 right? Keep adding. What's the chance you score more than 20? Not likely, because you expect to lose 5 points on this test. Rigged, man. So lower bound is what? 20. Upper bound. Yep, our high number. Mean or EV sum. Negative 5. SD or SE sum. And what's the chance? 3.2% chance of scoring more than 20 points if you just guessed. Okay, that's not very encouraging. All right, yeah. You're like, I just guessed. You were lucky. You were very lucky. I know. All right, so let's do one more example. Here we go. 10% of people in a large population are considered underweight. What would that be like? If we take a random sample, just kidding. If we take a random sample of 1,000 people from this population, what's the chance more than 103 of them will be considered underweight? So how could we make a box model where we can just count those skinnies? Just kidding. No offense to all you skinnies in here. Okay. Okay, so 10% of people. So we're just counting 10% of people are underweight. The rest we're not even counting. So what is the box model we can make where we count or have 10% of the number of tickets 1, everything else 0? Are there multiple possibilities I could do with this box model? Yes. Yes, there are. But somebody think, what's an easy one to show 10%? 1, 1, and 9 zeros. Why would that work, Jordan? Because the 1 is 10% of 9. 10% of the 10 tickets, right? Is there another way I could do that? Could I do 10 ones and 90 zeros? Would that work? Yep, and it would be the same thing. I just have to have 10% ones of the tickets in the box. Does that make sense? So I'm only counting those underweight people, okay? And then we're going to draw, or we're going to sample from this population how many times? 1,000. Good. Okay, and then we need to find the chance of this happening. So that means, what is the average of the box? This should be easy. 0.1, 10%. So the average underweight is 0.1, right? SD shortcut is large number minus the small number on the ticket. So that's just 1 minus 0. And then the fraction of ones times fraction of zeros. What's the fraction of ones? 1 out of 10. So fraction of zeros times 9 out of 10. Yep. So really, you can just go square root 0.1 times 0.9 if you wanted to make it quicker. And what is that, SD? 0.3 exactly? Okay. So now I want you guys with your partner go from there to find the chance of us sampling more than 103 people that are underweight. Okay. All right, Lydia, what did you get for the EV sum? 100. Okay, SC sum. Daniel, what'd you get? 9 point what? 48. Thank you. Okay, or some of you rounded to 9.5. That's fine. And then the chance of this happening would be the low in menu 652. Lower bound is what number? 103. What's the upper bound? And then mean or the EV sum 100, and then the SE sum is 9.5 or 48. And what's the chance of this happening? 37% chance that in that sample of 1,000 people, we'd have more than 103 that were underweight. Okay. All right. Question. Yes. Okay, so that the lower bound and upper bound are based on what the question is asking, okay? So with this one, it's like, what is the chance that more than 103? That's our key part that we want to focus on. Because then if I drew the normal curve, which I didn't, I should have, we have then 103, let's see, we expect 100, right? And the SC is 9. So 103 would be like right here, and we're wanting the chance that more than that. So then I would just shade this part, and I'm wanting to know that part of the normal curve. So then I can visually see, okay, this lower bound is 103, the upper bound is some high value, and that's where we put the 10,000. So by drawing the normal curve, that might help you like visualize what's upper and lower. All right, well, that's it for today. We're going to practice more tomorrow, so you guys can